Hello, and welcome to the webinar today. We're very glad that you are attending. My name is Luis Colon, and I'm a Senior Developer Advocate at AWS with the CloudFormation team. And I'm joined today by Richard Boyd, who's also a Senior Developer Advocate for the AWS Code Services team. Richard, you want to kind of like say a little bit about yourself?
Yes, my name is Richard Boyd. As Louis mentioned, I'm a Senior Developer Advocate for the AWS Code Services, as well as the SDKs and toolkits and our IDEs.
Great, thank you, Richard. So today we're going to cover infrastructure as code from a perspective of best practices, but also as an introductory presentation on what are the key things that you should think about if you've never done infrastructure as code before, but also if you have done infrastructure as code, hopefully you'll be able to glean some good advice from this. Infrastructure as code and CloudFormation and CDK in particular have been around for a while. CDK has been available now for well over a year and a half, and CloudFormation has been available for several years. And it's a good idea to kind of like review where we've gotten from the beginnings of this and when people have done infrastructure as code in other places. So hopefully you'll get a lot of good information as you plan to modernize your cloud application resources. So let's go ahead and get started. What we'll cover today is we'll first spend some time talking about the basics of infrastructure as code as a practice. Then we'll cover how CloudFormation implements infrastructure as code. Then we'll cover some best practices that, although we'll cover them in the context of CloudFormation and CDK, these best practices are very much used with any other tooling that you might be doing for infrastructure as code. And in many cases, they're good best practices for cloud workloads and applications in general. Then Richard is going to talk and do a deep dive a little bit on the CDK or the Cloud Development Kit. And then we'll finish by covering and kind of like mentioning other infrastructure as code tools, since we know that many of our customers not only use some of our tools, but in many cases, they augment that with their own custom homegrown programming or using other third-party tools, just to make sure that you are aware that, you know, there are other options, especially when you have applications that have been around for a long time and you might be looking at migrating those applications to AWS. So we'll start with the basics. How did we land here and why did we land here? So many businesses today have leveraged the cloud for a variety of reasons: scalability, cost effectiveness, and those cloud applications and workloads manifest themselves as an architecture that has a lot of components. And when we're talking about managing those cloud applications, we talk about managing the life cycle of those components or resources in the application. So for example, to use a very common example, if you have an application that is a 3-tier web application, you likely will have things like a web server, a persistence layer as a database, and other components of that application that they need to work together. So those applications, those components of the cloud application are essentially their resources. Here's a couple of examples of that. You'll probably have some compute resources, like in the case of AWS, things like EC2, Fargate, or other container type of resources. You may have also serverless resources like Lambda functions. Then you'll also have your persistence layer like databases, analytics layers like Kinesis, and security like IAM in the case of AWS. And when we're talking about managing the life cycle of those resources, we talk about creating those resources, updating those resources, and by updating we mean changing the state or the configuration of those resources, as well as when necessary, moving those resources or distributing those resources to other accounts of regions, and or removing and deleting those resources. And that's kind of like what we talk about here when we talk about the life cycle itself. Now, obviously, an application is not only a combination of resources. We also have to configure those resources in the right way. Many of those resources depend on each other. Sometimes when you are changing them, you need to be made aware of one change will affect another resource, so you want to make those changes in the proper order. And the combination of those resources and the configuration of those resources are what gets ultimately created as your application. So let's talk a little bit more about those resources themselves and how you're configuring them in places like a virtual private cloud, auto-scaling groups, etc. Those resources are the building blocks and components of your applications. And there are many ways to create those resources. What usually happens is that whenever you're starting to use a new resource, you're trying to learn about the resource, experiment, understand all of its configuration options. And many customers will start by using the browser-based AWS Management Console to create those resources. And that's something that even although you might automate those resources deployments over time in the future, you'll still probably use the Management Console either to inspect those existing resources or to experiment with new resources that your existing applications may need. Another option, and customers tend to gravitate towards using more automated options like the AWS Command Line Interface or CLI. When you're using CLI now, you need a little bit more expertise in terms of like what CLI commands are available for your service and your resource. But it also gives you the opportunity to put some automation around that, either by doing things like batch files. But this is the kind of thing that you start moving away or considering other options beyond the Management Console when you have dozens, hundreds, and in some cases thousands of resources. As you go through this transition and perhaps maturity of your cloud practices and processes, you will also consider to use things like more advanced tooling and AWS tools and SDKs. One of the reasons why you also have the option of using something like CloudFormation, which is an infrastructure as code tool, and we'll discuss here shortly what we mean by infrastructure as code, is that with CloudFormation, you'll get some of the benefits of the CLI and the SDK in terms of like more configuration and more automation. But CloudFormation also gives you the benefit of, although these resources like compute, database, security, and many other resources are very different, CloudFormation allows you a way, and infrastructure as code allows you a way to describe and configure those resources while abstracting some of the differences of those resources. And we'll discuss a little bit when we get into CloudFormation specifically, how CloudFormation goes about and do that. So these are essentially your options to manage the resources lifecycle, create them, change them, delete them, change their configuration. And we're today going to concentrate primarily on CloudFormation, and in a way also there's some overlap with AWS toolings like the SDK that we'll discuss as well. So before we start going too far into CloudFormation, let's discuss this idea of infrastructure as code. And for that, a good way to do it is by showing an example. When we talk about infrastructure as code, you're probably going to be talking about some file, some text file that represents your code. But for people that have not seen this before, it might not look like a code program, if you will. Here's a very basic example of infrastructure as code. When you look at this file, you'll see two resources. I'll have you concentrate on line 3 here. And those resources are some of those pieces of that application. In this very simple sample, our application has a compute resource, which happens to be a Cloud9 resource, a browser-based editor that AWS provides. and a code commit repository, which is essentially a Git repository. And in this very basic example, we configure those resources by specifying what the properties those resources should have. We can name them in the case of the repository. And we've also specified that the second resource depends on the first resource. When we do this, we're able to, in a single file, define a lot of resources or multiple resources, have those configurations for those resources there, and note that we really don't have to learn about the specific SDKs or APIs that create or change a code commit repository or a Cloud9 environment. And this is one of the benefits of using infrastructure as code. You define all your resources in a very similar way, specifying the intended state that you want those resources to have, and kind of like hiding some of the differences between how to configure a Git repo and how to configure a compute resource, etc. So when we talk about infrastructure as code in this particular style of it, we talk about doing programming in a declarative way. You don't care at this point when you execute this code, how does the backend system actually create that resource or change it. You want to specify what you want that resource's state to be, and let the system figure out what's the best way to achieve that. So when we talk about infrastructure as code, you are writing code to define those components of your application, those resources, and in fact define your infrastructure. And you do it in such a way that you try to concentrate more on the intent of what you're trying to create or trying to configure, and less about the particular way in which it's actually being configured. This is kind of like a very Bobby Basic way of looking at it, but it really kind of like captures the spirit of what you want to get accomplished with infrastructure as code. Because we're covering CloudFormation, this example is very specific to CloudFormation, but as we discuss later, some of the other tools that exist, many of the tools take a similar approach, where you have an infrastructure as code template or code file that describes the resources or the parts of your cloud workload and describes the configuration of that. And there's a lot of best practices as to how to tie the resources together and when to keep some of the configuration details in the infrastructure as code file and when to keep those details external to the file and have that configuration kind of like follow best practices like 12-factor applications. So when we talk about infrastructure as code, think about the code as, or one version of how to do the code in this declarative format. As we discuss CDK later, you will have also kind of like a hybrid way to do this in a more familiar high-level language, but in a way you're still concentrating on the intent of the resources that you create and less about how those resources are implemented. Of course, you can always go, if necessary, to the SDKs themselves and have a little bit more control. So with that in mind, let's kind of like focus on the thought of that code and that code template and how CloudFormation actually turns that code template into a real life cloud workload for your application. So as I mentioned, the code template itself describes the intended state of those resources. Then CloudFormation translates that intention to the underlying API calls. So if we were to look at a high level as to how CloudFormation works, we can create kind of like a diagram here to walk you through the process. So the first thing you would do is you code your template, you code your infrastructure. You're describing the intended state here. And you notice here, we'll use these icons to kind of like walk you through the process. So the way that you would code that is typically to a text editor. A lot of people traditionally have used very, very basic text editors, but we'll discuss later that because we've been doing infrastructure as code now for many years, there are some editor tools and some better editors and better IDEs and plugins which can make the process of creating these templates a lot easier. Also, we want to emphasize that as you're writing code, you also need to be mindful about testing your code. And there's many things that you can use to test code as early as possible. And we'll cover one of those tools that we provide as an open source project for testing. But there's obviously many tools that you would use for testing this particular code. But and you will be having opportunities to test that code in several places in your code's evolution. So once you code your template, the next step is to bring that template to the system or to the cloud and upload that template, do some additional testing, like integration testing, and review the changes. And this implies that you may have already an application where you're writing code to change an existing application. And we'll talk a little bit about change sets and how CloudFormation handles that to give you a preview of, even before you execute those changes, what those changes are going to be. Once again, in the CloudFormation case, once you have written your code, have uploaded it, have tested it and validated that you indeed want to execute it, the execution happens, and this code is translated, this execution plan that now has API calls, it's performed and it's executed. And it will be a series of API calls, but tools like CloudFormation actually add a little bit more smarts and controls there here too. For example, one of the things that CloudFormation will do if you have a template of, for example, 10 resources, is that CloudFormation will recognize which resources implicitly may depend on another resource by the way that you write your code, or you yourself can specify that a particular compute resource cannot be created before a database persistence resource is created, for example. Beyond that, we'll also ensure that before one resource is needed by another resource, we make sure that that resource is stabilized, meaning that that resource is available so that you can list it, describe it, and operate it. If you were doing this without an infrastructure as code tool and just writing the APIs via the SDK yourself, it would be up to you to start sending an asynchronous call to create a resource and then wait until that resource stabilizes. So the stabilization is one of CloudFormation's conveniences here. Another convenience, especially when you're updating an existing application, is that you can have CloudFormation essentially keep the state of that application, which what that means is actually keeps the configuration state of all the resources in that application. And then if for whatever reason there's a problem in changing a particular resource, CloudFormation can revert back to the last known good state of that combination of resources. And here we introduce the concept of a stack. The stack is essentially the implementation of the group of resources in your particular application or in that particular segment of the application, because when applications get big, you really want to have the control of changing parts of the application without affecting other parts. But the stack is has a one-to-one relationship in most cases to your application code template. So writing a template with 10 resources will result in a stack with 10 resources. With CloudFormation, we'll maintain that stack. We'll maintain the last known good state so we can roll back to it if necessary. And then we'll maintain that configuration and be able to tell you whether or not that configuration has changed outside of CloudFormation. Once that stack is created, you will then use CloudFormation and other tools available to be able to manage those stacks, whether or not you have to change the stacks, refactor them, delete them, move to other places and other regions and other accounts, etc. We'll touch on this a little bit later, but CloudFormation also allows a way to have a stack set. And a stack set is essentially that same grouping of resources represented and deployed across more than one account and or more than one region. So reviewing here, you write your code and test it as early as possible. You review the changes that are going to be in the execution plan on that code. You either create or update the grouping of that code or the stack. And then you manage those stacks over time to implement changes to the stack, which ultimately are changes to your resources. Now, there's a lot more about CloudFormation that we can talk about, But let's kind of like discuss at this point some of the best practices that we've seen in working with customers for many years and working with hundreds of thousands of customers, not only startups and small companies, medium-sized, very large companies, multi-country enterprises, global enterprises, and even internal users of CloudFormation. As you can imagine, AWS has a lot of workloads as well, and CloudFormation is heavily used internal to AWS as well. As we talk about these best practices, let's kind of like talk about them in the context of these core artifacts that we've mentioned here. We talked about the template, which is the key code file that starts all this process. And this is the file where you describe your resources, those attributes or properties of those resources, the dependencies between those resources between each other, and then the intended state or configuration of that resource. We touched upon stack sets, which once you have a declaration that you want to create resources or change their state, we'll evaluate that intent, if you will, and then tell you via change sets whether or not your second resource will change, whether or not changing that resource will force that resource to be recreated, because the change might be immutable, and that sometimes will happen, and you need to be mindful of that, because by recreating that resource, deleting it and creating it again, you may be impacting things like other things that depend on that resource to always be there. So evaluating change sets it's critical, and it can be a very powerful thing to predict and to move you towards kind of like having a good change control process. In many cases, the best practice is to try to have applications where your infrastructure is immutable, meaning that it will become easier over time to be able to say, I want those resources to be replaceable, not depend as much on each other as possible, and be able for your application to recognize that if a resource doesn't exist, it can be quickly replaced. When people talk about immutable infrastructure, they'll compare it to classical infrastructure where you will take a resource like a compute instance and upgrade it in place. Upgrading in place sometimes can be faster, but as you have multiple dozens or hundreds of resources, upgrading those resources in place might make them all different, and that can have some challenges. Whereas if you use infrastructure that's immutable, and if you're using resources like containers and serverless, you'll have a little bit more confidence that you can treat those resources in a disposable manner. And in many cases, it makes a lot more sense to create a brand new resource with its new current state out of a golden master copy rather than upgrading resources in place. So these are the kind of things that the change set will give you information whether or not a resource has to be replaced or not, and you need to take that into account. We touched on stacks, that once we have this grouping of resources represented as a template, that grouping of resources and their configuration will be represented and maintained, in this case by CloudFormation, by us. The stack changes can roll back, as I mentioned, to their last known good state. Stacks can be organized in many ways. Stacks have some visibility to each other, and there's ways to create stacks so they can talk to each other. They support resource dependencies, whether they're implied, meaning that you don't necessarily have to tell us that one resource has to be created before the other, or explicit, where you specifically want to enforce that a resource gets created before another one. And then we provide for stabilization, as we mentioned before. And then we touched upon stack sets. And stack sets tend to be kind of like an advanced implementation for companies that do have multiple accounts, and they'll want to use those accounts for workload isolation, or they, because of the requirements of their application, they want to spread that account across geographical regions and geographical traffic. Of course, you'll have applications that will be across availability zones for you to have high availability, and stack sets can also help with that. So in case of this core artifacts, let's talk a little bit about what best practices you can apply as you think about these core artifacts. We'll start with templates. Here's again the sample that we used before. you have a couple of options as to write the templates with CloudFormation. Traditionally, we have used JSON, and that's still a very good option for people to write templates with, especially if you're going to do advanced things with your code, like, for example, parse the code with other applications, since parsing JSON in general tends to be a little bit simpler than parsing YAML. But most users will probably recognize YAML as a much more readable way to create templates. There's some differences between YAML and JSON. One of the things that I'll highlight here is that you can do inline comments by using the 2 pound signs in YAML, but JSON as a standard does not support comments. So this is not necessarily a characteristic of CloudFormation, but more about JSON versus YAML. But you do have the flexibility to pick one or the other. In CloudFormation, we first supported JSON and started supporting YAML about 4 years ago. So you still will find a lot of CloudFormation samples out there that are represented in JSON or YAML. As I mentioned, YAML allows for comments. If you do find samples on JSON out there, you can use a tool like CFN Flip, which can actually change the format of the file between JSON and YAML. And you also have the capability to use other provisions, like, for example, you can use macros, which can help you do transforms in your template. And you can use includes from other templates, not unlike how you would use include in a programming language. There's also some convenient features like the serverless application modeling or SAM, where if you're writing Lambda-based applications, for example, in AWS, you can use SAM as a shortcut so that when you write a serverless resource, it actually generates other resource behind the scenes for you. And you can do something similar with macros as well. When you look at what kind of resources you can create, you now look at AWS that has over 200 types of different services in compute, database, and others. And then for each one of those services, there are a lot of resource types. Today, we support well over 500 types of resources. And in cases where a resource is not available, you can create your own. And we'll talk a little bit about that as well. In terms of a best practice to follow with templates, although you can put hundreds of resources in a template, it's easier, especially with large applications, to be able to write and troubleshoot and test smaller templates. So also it gives you the benefit of, if you're changing a smaller template, meaning that you're changing less resources in your application at any given time, you're essentially controlling the blast radius of your change. So this can become very important if your application or your workloads use dozens or even hundreds of resources. So although you can put a lot of resources in a single template, in many cases, it makes a lot more sense to break that into smaller templates. We touched upon, when we first mentioned templates, that you want to not only use a good editor to actually change these or write these templates, but you also can leverage plugins. Specifically, I'll mention one called CFN Lint. CFN Lint can actually provide you a lot of conveniences as you're writing your template. We'll actually check for things like the resource configurations and warn you if a particular property or attribute of the resource is invalid. And you can change that as you're writing the code, as opposed to incurring more delays by not recognizing that error or change until you try to push the resource into production. Beyond those conveniences, the CFN linter has been around now for a couple of years, and it has many other features. The one that I'll highlight is that you can create custom rules that allow you to even have a little bit more compliance as you're writing your code. An example of a rule might be, although we allow you to create an S3 bucket for storage that is not encrypted, you can have a rule that everybody in your organization uses to say, although you're able via CloudFormation to create that bucket, you want to enforce a rule to say, I don't want to allow anybody in my organization to create a bucket that's not encrypted. So you can extend CFN Lint with these types of rules. And as a best practice, we not only recommend to use CFN lint when you're authoring, but as you're deploying your template and deploying your chain set, that you leverage things like a CI/CD pipeline, and then use CFN lint in a headless mode, just to make sure that anybody that can be writing infrastructure as code tool for your behalf are truly evaluating all the rules that I mentioned. So when you use CFN lint, think about using it when you're authoring templates, but also think about using it as one of your build steps in your CI/CD pipeline. On chain sets, we discussed this briefly in terms of like, you can create a chain set not only when you're changing an existing stack, but you can also create a chain set, this kind of execution plan, even when you're creating a new stack from scratch. You can set up your pipeline as well, such that rather than deploying to production directly without approvals, that you actually generate a chain set and then have somebody manually approve that the chain set indicates whether or not things are going to be properly updated or resources are going to be properly changed. So the changes, besides the extra information that they'll tell you about the mutability of your changes, it can be an opportunity also to be able to say, I'm going to allow an admin type of user to say, approve the change set before you actually push things into production. And that's a good best practice as well. So although change sets is relatively recent in the history of CloudFormation, I think it's been available now for about 4.5 to 5 years. We still recommend to customers to leverage it and to ensure that they're kind of like taking advantage of the fact that you can use a change set as part of your approval process. Let's talk about stacks. When we touched upon before that you can take your application and your workload and put it all, in many cases, in one template, but we recommend that you break that and kind of like layer your application. On the visual here on the right side, we kind of like indicate, imagine if you had an application that includes things like IAM users, groups, roles, and policies, and includes things like backend services and front-end services, for example. In many cases, you can put these things all in one template. But now every time you need to change something that changes frequently, for example, and in this case, probably your most frequent change is going to be your application compute binaries, you will be changing the same file that potentially can change the rest of your application. So once again, the blast radius of your change might be more significant than what you intended to be. And sometimes you'll change users and groups a lot less frequently than you'll change your binaries. So we recommend that you kind of like layer out your application and put these series of resources on different stacks based on their life cycle or based on how often do you have to change them. Once again, for a typical application, you probably won't change the database or its schema as often as you would change the application binaries to add features. Another thing that is a good practice that we kind of like mentioned earlier before is this idea of 12-factor apps. And really the idea comes from trying to extract as much configuration as possible for your template. And that might kind of like strike you as, well, I thought the template was to specify the configuration. And it is. But there's a couple of things that you can do in terms of extracting that configuration that makes that template a lot more reusable. And by making it more reusable, you can make sure that your applications in your company have a more uniform configuration. Here's a couple of examples. The one example that I'm showing here is about the creation of a RDS database. Not only would you not want to put the password in a file that could be seen by other people in your company, but if you keep those passwords kind of like in a centralized place, for example, in AWS Instance Manager, then you can change the password in one place, and then any execution of your templates will just refer to that password there. That's just one example of not only how to make that template more reusable, but also to make it more secure because you're not putting that secret out there wherever your code is. And in general, you will do this even with other code that's not infrastructure as code. Another way that you can make your templates and thus your stacks more flexible and more reusable is by leveraging parameters. So you can essentially have the same exact infrastructure as code template, but come up with two completely separate sets of parameters such that you can use the same template, the same rules, and the same thing that you've tested over and over, but be able to change the particulars of the configuration for a different account, for a different environment, like development versus staging versus production, or a completely different region. And when we're talking about that, we'll cover stack sets. The idea between stack sets is that you can have kind of like a stack like you would have in your primary account, and then be able to say, I want to replicate that stack across other accounts and other regions, but still have the same controls and the same configurations and the same rules applied to those. So obviously you can do this manually by having more operations in terms of like more stack creations, but that can become a little bit complicated if you have dozens of accounts. So stack sets are a convenient way to say, with one single operation and with one single template, update a lot of resources, related resources, in a lot of places at the same time. And here, in terms of best practices, some of the same things that we talked about before with templates and stacks apply as well. A more complicated stack set, a larger stack set coming from a larger template will be a little bit tougher to troubleshoot and to test. So smaller stack sets also benefit you here. Also in stack sets, you can do things like, since you can actually make a lot of changes in parallel, which may result in a large blast radius for your change, you can make the stack set say, if I'm updating 10 stack instances, for example, and I start getting errors, you can say, I'm going to allow for 2 errors to happen and still update the stack set, or after 2 errors happen, kind of like revert the stack set operation. So there's kind of like a failure threshold that you can control there. You can also control parallelism to say, although I'm going to be changing 10 instances across many accounts and regions, I'm only going to change 2 at a time. So if you, kind of like in a canary approach, if you see that there's some issues and everything, you can revert back your changes to that stack set before you change all of the instances in your operation. So in terms of best practices, stack sets, small is also better, easier to test, and take advantage of the failure thresholds and the parallelism controls that you would get with stack sets. Before finishing this discussion on best practices, there's a couple others that I will highlight for you. One is drift detection. And configuration drift, or more simply drift, is defined here as, if you create those resources with CloudFormation, create those production resources in CloudFormation, which many companies do, the best practice is to try to make those changes also through CloudFormation, so that CloudFormation is aware of the resource's state, and you have a centralized place where you can keep that state for that resource. However, sometimes because of an emergency, you may have to change that resource outside of CloudFormation, or there might be other reasons why that change is necessary. And in the case of an emergency or a downtime event, sometimes it is inevitable. But the side effect is that now the state that CloudFormation persists for that resource is different than what that resource looks like in real life. So the configurations has changed or drifted. CloudFormation provides for a feature called drift detection, where we can compare not only for a stack, for a resource, or also for a stack set, whether or not the configuration still is the same as the one that CloudFormation is persisting. And if it isn't, we can highlight that it isn't. When you use drift detection in the console, which you can also use via APIs, we can highlight whether or not an element of your configuration changed, like here the instance type has changed, whether or not a particular parameter or a particular attribute has been deleted, or whether or not somebody has added more configuration outside. Drift detection is available for most of the more widely used resources, but not all 500 or so CloudFormation resources. But you'll see that most of the common ones do support drift detection. And then you can remediate that drift in different ways. For example, if you added something outside of CloudFormation, sometimes it's a good idea to re-import that resource into CloudFormation to just catch up the state to what CloudFormation is saving and maintaining. When the resource is deleted, then you can, possibly kind of like recreate the resource. So there's, in terms of like remediating drift, it depends a lot on what caused the drift in the first place and whether or not the resource, for example, is a resource that carries state. It tends to be a lot easier to address drift with resources that don't save state. And it can be a lot more complex for resources like queues and databases that do hold state. So be mindful about drift detection and leverage it as much as possible. If you have an environment where a lot of changes have to happen outside of your infrastructure as code tool. Finally, I'll mention the CloudFormation Registry. Traditionally, and CloudFormation has been around for quite a while now, and whenever you have the necessity of having a custom resource or a resource that's not yet supported by CloudFormation, or supported by CloudFormation, but a particular API call is not supported by it, you can create your own custom implementation of that resource. With Registry, you can discover all the resources that are supported with CloudFormation, and now we provide a way for also third-party vendors to also distribute resources that are based on CloudFormation as well. And you can have your own private resources where either you can create a resource that, again, does not exist, representing an API call that is not supported, or you can create your own combinations of resources, or you can create resources that encapsulate third-party calls from a remote API or a local data center. So whenever you go beyond what you can do with the supported resources in CloudFormation, CloudFormation has the extensibility option of being able to create custom resources and customizations in several ways, and Registry is one of the latest ways to do that. We provide a CLI tool to make it easy to create registry resources, and you can create registry resources with languages like Java, Python, and Go. And you can also create custom resources that are backed by AWS Lambda functions and support all the languages that Lambda functions support. So that covers the basics of infrastructure as code, ideally why you would want to do it, especially if you have a lot of resources. How does CloudFormation implement things at a high level using templates, chain sets, stacks, and stack sets. And we covered a little bit of best practices as well. We covered infrastructure as code from the perspective of a declarative code sample, but CloudFormation allows for other ways to actually create your infrastructure. So I'm going to turn it over to Richard now, and he's going to cover the CDK or Cloud Development Kit as an attractive alternative to create infrastructure as code as well while leveraging CloudFormation. Richard?
So next we'll cover the AWS Cloud Developer Kit, or CDK. The CDK is an open source tool that AWS created to simplify infrastructure provisioning. This tool allows you to model your infrastructure as reusable components that you can share both publicly and privately. So you can put them onto npm.js or Maven Central to share publicly, or if you use a private artifact management service, you can share them there as well. And what this allows you to do is use a lot of the same IDE tools that you're already using, such as if you're using an IDE that allows type hints, you get that same effect in your construct authoring experience here. So you know that it requires something along the lines of domain name or zone, but you can't quite remember the syntax. You can lean more heavily on your IDE to smooth out some of these rough edges for you. And it also allows you to read some of the docs that are generated with constructs, the same way you would if you're using a third-party resource such as Python's request library that has docs associated with the APIs, so you know what type of properties it's expecting and what it can return to you. So authoring your infrastructure feels more like authoring application code instead of a separate process. Today we support 5 languages at general availability inside of CDK, including Python, JavaScript, TypeScript, Java, and C#. You can write CDK in any one of a CDK application in any one of these languages, But if you choose TypeScript, we have another tool that we published that allows you to write it once in TypeScript and then publish it out to the other 4 languages so that you can write a construct in TypeScript and share it with someone who wants to use it in Python or share it with someone who wants to use it in Java. So I've mentioned a couple times about how we write CDK and how that helps. Let's look at some of the mechanics of how that happens. Authoring CDK constructs starts with the CDK CLI. This allows you to interact with the CDK framework to author these constructs in the source code, which includes apps, stacks, and resources. And then once your authorship is done, you can then use the CLI to synthesize your CDK application into a CloudFormation template in a collection of assets such as Lambda function code or ECR images that are then published to CloudFormation or to an S3 bucket to support that CloudFormation deployment. And then we rely on CloudFormation to do the provisioning for us once we've provided that template. CDK has 3 main components: the core framework, the construct library, and the CDK CLI. The core framework defines CDK applications, CDK stacks, and resources. Similar to how Lewis mentioned that CloudFormation supports over 500 resources, CDK also supports those resources, but we have some high-level abstractions that sit on top of those that are also included in CDK. Next, we have the construct library, and this is a collection of those resources, both the CloudFormation resources and these high-level abstractions that are grouped together according to the AWS service that they come from or according to some kind of use case. And finally, we have the CLI. The CLI is how you interact with both parts of these things for synthesizing a template after you've authored it, using the initialization command to generate a template from a template so that you can say, okay, I want to start with some basic application and then kind of tweak it a little bit and then synthesize and deploy it. It also allows you to do CDK deploy, which will send these changes to CloudFormation to have them provisioned, or CDK destroy, which allows you to tear down the resources, which is very useful in like dev and test environments where you just want a one-off change that it's not necessarily worth the overhead associated with setting up a full CI/CD system just for a dev environment. Now, because CDK supports familiar programming languages like TypeScript shown here, you can rely on your existing software development tools and practices to ensure a high-quality infrastructure configuration. You'll catch errors in like the types of properties that are passed in, or you can assert on the responses that come back so that you're not going to be caught up by either syntax bugs or misunderstanding the type from a particular resource. So here's an example of, on the left we have CDK Sample Code, and on the right we have CloudFormation. These two examples aren't necessarily related, but it's just to demonstrate the difference between the two. Whereas on the left you see that API gateway .REST API is a method that you call generates REST API that we're going to call API, and then we can pass that around as an API that we see in the health monitor later on. So we're not worried about the specific ARN or some string that identifies a particular resource of the API. We can just pass the API around and let the underlying resources extract the information that they need from that so that it frees us up to think more about the business logic of what the application is doing and less about the mechanics of how I share information between resources. We see something similar in the CloudFormation template on the right, where we have the repo with the clone URL HTTP, which we would get from the documentation for CloudFormation that says what attributes are available on that repo. The CDK constructs come in 3 main types. The first one we call L1 constructs, and these are all of the CloudFormation resources that are in the CloudFormation specification that Lewis mentioned earlier. He said that there was over 500, and these are immediately available inside of CDK. So if it's supported in CloudFormation, it's immediately supported in CDK. And it's a one-to-one mapping of CloudFormation properties to CDK properties. And this is good as like a very broad base of coverage to make sure that we're providing at least as much functionality as using CloudFormation directly. But where CDK really starts to shine is when we get into L2 constructs. And these are higher level abstractions with sensible defaults that are built on top of the L1 constructs. So an example of this is the AWS step functions domain-specific language that exposes specific methods on the states, such as next and catch, that simplify this authorship experience for writing a step function. So you're not writing just straight JSON that has to define this entire spec in the Amazon states language. You get to lean on your IDE to fill in some of your knowledge gaps, so you can say, I think this method starts with is it next or next state? I'm not too sure. You just press .n, and then it'll show you in the type completion the available methods that are there. And then finally, we've got L3 constructs. L3 constructs are a collection of L2 constructs, possibly spanning many different services, or sometimes they only span a single service. And these provide patterns of architectures that tend to be used together as a easier onboarding, like turnkey solution for using CDK. So one example is this application load balanced Fargate service pattern. This creates a set of defaults for almost every option. So you only have to provide like the bare minimum to get it to start running. And you can peel back the abstraction as you need to. So if you needed to add maybe the port that the load balancer is on, you need to change, you can apply that setting, and you can apply just a couple of settings at a time and slowly override the defaults until you get it exactly where you want. But you can start with saying, I don't care about any other settings, I just want something that works, and then I can tweak it until it gets to what I want to do. And that's what these patterns help you do. So when you deploy this pattern, it'll create a VPC with subnets, elastic IPs, NAT gateways, creates load balancers, a Fargate service, ECS task definition. I'm not going to read the whole slide to you, but you see like all these resources that are created from just 4 lines of CDK. Because we provide a lot of these values set at defaults. So I believe in this particular example, it comes with, the VPC comes with 2 private and 2 public subnets. But if you say, no, I very specifically only want public subnets, you can add a setting inside of this constructor saying, only give me public subnets. And within reason, like that'll always work. But there are cases where you might say, I want a public subnet, but for whatever reason, the use case doesn't support that. Then CDK will throw an error saying, I can't find a private subnet, and it's the only thing that's supported here. Because the subnet type is identified as an object-oriented type of private subnet, we can differentiate between public, private, isolated subnets so that we can expose to the user, hey, you're about to put this thing into a public subnet. Did you intend to do that? Or, hey, you're about to put this public-facing website in a private subnet. Did you intend to do that? And it gives you a much better sense of what's happening than using just pure CloudFormation syntax. And with this, I'm going to hand it back over to Lewis to talk about some additional tooling options.
All right. Thank you, Richard. Something that CDK has made a big impact on us as CloudFormation customers have told me is the powerful constructs are something that I think it's one of the more popular areas of CDK. So thank you. So now let's finish up by covering additional tooling options. Because as you can imagine, infrastructure as code has been around for quite a while, and there's a lot of applications that sit in AWS and not in AWS that leverage this. There's a couple of additional tools that you can leverage in AWS beyond what we discussed here today, which was CloudFormation and CDK. Specifically, there's a couple of them that I want to highlight. The first one is called AWS OpsWorks. And AWS OpsWorks is essentially a service where if you have used infrastructure as code for applications that perhaps have lived before in your data center, you may have set up those applications with tools like Chef and Puppet. In fact, in my past, I know that the first time that we started doing CI/CD before I got to AWS, we used Puppet as our infrastructure as code tool. So with AWS OpsWorks, you can actually have a managed instance of Chef and or Puppet, and you can use those tools and their specific language conventions to model and provision and deploy applications. So many customers have leveraged their existing investment in Chef and Puppet code and recipes and runbooks and everything. And in some cases, they'll use those. In some cases, they'll transition them to CloudFormation and other tools. And in many cases, they'll use them together. So if you have had a large investment on things like Chef and Puppet, Opsworks might be a compelling option for you to integrate with CloudFormation as well. Service Catalog is an interesting option as well, in that once you have companies that are larger, that have a lot of applications and tons of resources, not only do they want to have people that perhaps have been SREs or sysadmins manage their CloudFormation, but they also may want to vend applications to other people that are less technical. And Service Catalog can actually allow you to create a portfolio of applications where behind the scenes you're deploying the application with CloudFormation, but the people requesting and using and changing those applications need to know very little about CloudFormation or the tools behind it. In many cases, those people can just change the parameters or the particular configuration attributes of the application, and behind the scenes, CloudFormation will actually do the heavy lifting. So think of Service Catalog as a way to leverage CloudFormation without having to learn or maintain CloudFormation code. And it can be a very powerful turnkey way to leverage infrastructure as code, while at the same time isolate a lot of your non-technical users from the details of infrastructure as code. So these tools have been available as part of AWS's series of services for quite a while now. They're pretty mature. And if you haven't seen them, I recommend that you take a look at them. Beyond what we provide as AWS native services, you also have third-party options, especially if you have non-AWS resources that you need to maintain. One of the popular ones that I'll mention here is Terraform, which is made by one of our APN partners, HashiCorp. And their open source engine is widely used for creating non-AWS resources and AWS resources, as a matter of fact. And they also have a similar kind of like domain-specific language convention in terms of like having kind of like a declarative approach. I mentioned Chef and Puppet in the context of Opsworks. There's still a lot of people that also can leverage Chef and Puppet, especially if they have a lot of investment on that, and use them directly with their AWS workloads. You also have Ansible and SaltStack, which again have been around for quite a while, and they're also considered infrastructure as code tools. They can help with a lot of, especially if you have a lot of resources in your data center and are looking for integrations between those resources and your cloud resources as well. And as you can imagine, many users of infrastructure as code and CloudFormation will sometimes use CloudFormation in combination with some of these tools. I'll highlight another one called Pulumi. And in Pulumi, you have a similar approach of creating your infrastructure as code in a high-level language and then have that translated to APIs as well. And Pulumi also covers different ways to deploy applications, much like CloudFormation does in terms of like deploying compute applications versus containers and other use cases as well. And there are some more third-party options out there. And in many cases, because of your particular circumstance, you might want to leverage those tools or use them in combination with some of the AWS tooling as well. So in summation here, we wanted to get across the fact that infrastructure as code as a practice is considered a best practice because once your applications become more numerous and you're using hundreds, if not thousands of resources, it now makes maintaining those cloud applications and those resources more repeatable, it's safer, auditable, and you can leverage that, especially for AWS and non-AWS resources as well. AWS provides multiple options for IAC. CloudFormation is, as I mentioned before, been around for several years, and it's used by hundreds of thousands of customers. We recently deployed CDK, and it's become a very popular alternative to writing CloudFormation template code versus writing, for example, JavaScript and TypeScript code. And that these best practices I wanted to highlight specifically, that they apply across the tools that we talked today and many non-AWS tools, like make changes as small as possible, make more changes with smaller pieces of code, be mindful about your blast radius, start evaluating and testing as early in the process as possible, implement your rules, etc., etc. There's a ton of information out there that you can learn from AWS and other sources about CloudFormation and CDK, and I'm just highlighting a few here. Also, as you're looking at learning more about this, or if you're already using them and want to learn the latest and greatest features and best practices, feel free to get in touch with your AWS contacts, account managers, for example, and they can get in contact with people like Richard and I as well. In fact, for CloudFormation and CDK, we have a very active customer community on Slack. And if you're interested in participating on that, have your AWS contacts get in touch with us, and we're happy to have you participate with us and learn from other customers as well. We'll use the remainder of our time here for question and answer, although I know that you guys have been also asking questions as we're going, but we'll use the remainder of time for that. And we'd like to thank you for taking time out of your busy day to actually share some time with us and discuss these things with us. We're obviously very passionate about what we're doing here and with infrastructure as code and CDK and CloudFormation, so we're happy to spend this time with you. And now let's turn it over to questions.